Hi, this is Miss Gonzalez. Today we are going to start our lesson from home. I wanted to start with recap exponential functions before we left. Exponential functions has the form y equals a times b to the x, where a is your starting point and b is your growth factor or decay factor. If you're growing by percent, it would be 1 plus the percent as a decimal, or decay would be 1 minus the percent. Otherwise, you might be doubling, tripling, and your B would represent that. Maybe once this pandemic is over, we will have some interesting data to actually look at what the actual growth factor for the coronavirus is. So to start, I wanted to review how to write equations. That's where we left off. So some of the equations, which we've already done, you might have in your notes if you actually have your notebooks at home. If not, use this video as a resource and just keep clicking back to it as many times as you need. So to start, we went over examples like this, where A is given to us because A is your start and A is when X is 0. So here we know A is 3. What would A of this one be? 6, correct. So since A is 3, I can go and write y equals 3 times B to the X. So now what I have to figure out is what is the growth factor. So now I would plug in what I know from this point to be able to solve for B. So this would be 75 equals 3 times B to the second power. And now you would solve for B. First step would be divide by 3. Pause the video if you don't have a calculator so you could do this with me. 75 divided by 3 is 25. Good. And then we would have B to the second power. How do we undo the power? Well, we take the square root of what that power is. In this case, it's 2, so it's the normal square root. If it's any other number, you can use your calculator by first putting in, for this example, would be 2. Then you would go to math in your calculator and hit math, number, and you'll find the button that has the X with the square root, and then you could put 25 in. That is the other option. It especially would come in handy if this exponent is anything but 2 or 3, because those are the only things that show up nicely in our calculators. But we all know the square root of 25 is 5, so B has to equal 5. Now we have everything we need to write our equation. So y would be equal to 3 times 5 to the x power. If you have any questions, please feel free to ask them. Ask me for another video. At the end of this Nearpod lesson, I will have a Flipgrid questions for anything that you might be stuck on. That's going to be what I'm going to try to do for our conversations. To me, I think Google Meets might get a little bit more complicated. So I'm going to try the Flipgrid outlet first, and we'll see how it goes. We're learning, and please share any suggestions you may have. So that is recap number 1. I think we actually had this exact problem in our notes. So maybe take a look at that and make sure you had it. If not, you could start fresh and write it down. So the next type of example we looked at was problems like number 19, when what happens if I only have nothing? So I have 2 points and I don't have the A or the B. In this case, when you don't have the A or the B, you're going to have to write 2 equations, and then we solve it as a systems of equations. So the first example would be 6 for the Y equals, I have no clue what A is, I have no clue what B is, and X is -2. The second equation I can write is 1 equals A, we don't know again, B, we still don't know, and the exponent would be 3. So now I want to figure out, well, where do I go from here? So what I would do is pick one of these 2 to solve. We did this one. It is probably easier to solve the one that has a negative point because of the negative property. So we would divide both sides by B to the -2. So that way we can plug in and use the substitution method of solving a system. So if you remember from our negative properties, you're not allowed to have a negative for an exponent. So this would move to the top, making this 6b squared is equal to a. So now what I could do is plug this in for a in this equation. So I would say y equals 6 times b to the second times b to the third. Properties of exponents, when we multiply, what do? Add. Very good. So we're going to have 1 equals 6 times b to the 5th power. So now you would solve for b similar to how we did over here. You would divide both sides by 6. And then you're going to take the 5th root. I wish I had a screen for the calculator, so please just let me know if you have any questions. But what you're going to do is you're going to go into that math part of your calculator. You're going to hit 5, that x square root button, and then 1 divided by 6, and that should give you 0.7. So b is equal in this case to 0.7. So this would be an example of a decay problem. Does that make sense? Well, let's look. -2, 6 would be a positive y, and then by the time you get to 3, you're all the way down at 1. So we are decreasing. So this is a decay model. This being less than 1 shows us that we do have a decay equation. So now that we have our b, we're not fully done yet because we still need to know what is a. So now I can use one of my points, doesn't matter which one, and plug it in. So 6 is the y. A, we are not sure. 0.7 to the 6th power. So I'm going to divide 6 by 0.7 to the 6th power. So 6 divided by 0.7 to the 6th power is going to be our A. So 6 divided by 0.7 to the 6th power. If you have your calculators, go ahead and put it in with me, is around 51. So we would have an equation, 51 for the A, 0.7 for the B. Sorry, the parentheses aren't that pretty, to the x power, and we say that is y equals. Hopefully that is a good recap. Again, if you have any questions, feel free to ask me any. I am going to put the next slide is going to be a couple of these examples. If you have the worksheet, you could do your work on a piece of paper. I'm going to screen them for the next one so you can upload. And you can either upload the text or a picture, whichever one is better for you. I think I'm going to have you do 16, 20, and 22. So those will be your next 3 slides. So we can just have a quick recap, and then we're going to look at how we use our calculator for modeling the regression. Great. Thank you.